Hello there. In this video we're going to look at some more trigonometry, but we're going to add a little bit of extra stuff, so a wee bit of vocabulary that we can help to solve some problems involving angles and distances. And the thing that we're going to add to our knowledge is the idea of angles of elevation and depression. Okay, sounds a bit sad, but it's not really, because depression actually has a number of different meanings. Elevation, to elevate something, simply means to lift it up. An elevator, we talk about going up in an elevator. So elevate means to lift up or to go up, and to depress, as you would depress a button, means to push it down. And that's where we get the word in the English language, a depression in terms of an emotional state. Is about just feeling as though things are pressing down on you. So depression just means to go down or a downward direction. Okay, so what does that mean in terms of angles and right angle triangles? Well, here we've got a building here. You might recognize it or not, the Petronas Twin Towers from Kuala Lumpur. They've been in quite a lot of movies, people abseiling down them and stuff like that. So say we've got a young man somewhere down on the ground here, and he's admiring his girlfriend who's climbed to the top, and she's up here, and they're kind of waving to each other at a distance. So we could say that the person, in order to be able to see somebody at the top, you've got to be, you wouldn't be able to see them if they were right at the bottom. So we're imagining that in order to see them, the person is standing away from the tower. So there will be a certain distance that they will be along the ground. So we imagine we could measure that distance to the bottom of the tower. Now, imagine looking up means that you can make a line of sight. Okay, so in other words, the idea is that we're thinking about this direct distance here. Now, they could be holding a piece of string or a thread. It's unlikely, but we can think about it as a visual line of sight, a straight line from one person to the other. So on top of that, we're imagining that the tower is a straight up and down vertical line. So you can see here that we've actually got a right angled triangle going on. Okay, that's not maybe a new thing. We've got a right angled triangle. If I move the notice, okay. So the angle of elevation is the angle which you would go from the horizontal. Here's the horizontal line. An angle of that a line is above the horizontal. Okay, so this is the angle of elevation, because the horizontal line there, the line that we've got, or this line of sight, is above the horizontal, and the number of degrees that would be, say that's we said that was 35 degrees it was measured. We could say the angle of elevation would be 35 degrees. In other words, it's a line which is above the horizontal. So in other words, just to recap here, okay, the angle between your line of sight and the horizontal looking up, it's often a line of sight. It could be a physical line, a wire, or a solid object, but we can also think about it as a line of sight. So what's an angle of depression then? Well, we can imagine that the person, the girlfriend who's up here looking down, well, if you think about that line of sight, if you were standing at the top of the tower and you looked straight ahead, then what would happen? You would actually be looking there, okay? In other words, she's got to look down to see him. He's got to look up. He's craning his neck back so that he can look up. But the girl's looking down. In other words, she has to have a line of sight which is below the horizontal. Now notice they've both got different horizontal lines, okay? So this angle here will happen also to be a certain amount of degrees down from the horizontal, and because it's below the horizontal, we call that an angle of depression. Okay. Now there's a fun little angle fact that you might remember, and that is that where you've got two parallel lines, these lines are both horizontal, which means that these two lines are both parallel. And where we've got a Z-shaped angle, okay, you ready for this? Where we've got a Z-shaped angle, the two angles at the corners are equal. Okay, so there's a kind of nice little symmetry going on there, if I'm trying to really muck up this diagram. So if that angle there is 35 at the bottom, then the angle here is also 35 degrees. It just so happens that one's looking up and the other's looking down. So an angle of depression is an angle between your line of sight and your horizontal looking down. So it simply helps us to identify if something is up from straight ahead or if it's down from straight ahead. Okay, so let's look at problems, a couple of problems involving angles of elevation and depression. Example 1, at 250 metres from its base, the angle of elevation to the top of Paisley Town Hall is 32 degrees. Calculate the height of the building. Well, there's no picture here, so we're going to have to construct one. Okay, so we imagine we've got the ground. Oops, I don't know why I've got an arrow there. Let's get rid of it. We've got the ground here, and the top of the town hall, just kind of identify the top of the town hall by a line. We could draw the whole building, but there's no much point. So it's being represented by this line here. And what we're imagining is that somewhere along here, we're standing 250 meters. Let's say we're standing here and it's 250 meters away, 250 meters away. Now you might be thinking, hang on a minute, if I'm standing, then my line of sight doesn't go from the ground. You know, it doesn't go from down here. It's going to go from here. So you might be thinking, surely my line of sight will go like that. And you'd be absolutely right. And there are some problems that you might come across where you have to take that into account. In other words, if you use trigonometry, you're actually talking about it, say maybe a meter or a meter and a half off the ground. Okay? At this distance, now, and the further you are away from something, the height that you are doesn't really make much of a difference. Okay, so I'm going to assume at the moment 250 meters is quite a long way. So I'm just going to assume that my head height is at the ground, just so that it simplifies the problem. And I don't think it's going to make too much of a difference because it's so far away. Okay, but you might see that in some other problems. So what we're going to do, we're going to draw a right angle to show the building straight up. Hopefully it is anyway. We've got 30. Now the angle of elevation is 32 degrees. So there's the horizontal, and looking up tells us that that's 32 degrees. So you just got to know what that angle of elevation is and not panic when you see the words and go, oh, I don't know what that is. Calculate the height of the building. I'm going to call that H, and therefore that's my problem. If I'd given you that triangle at the beginning, I'm sure you'd probably have been able to work out the height, but you've got to put it all together. So let's just quickly do that. If you want to pause the video and try it yourself, then by all means. So here's the hypotenuse, here is the opposite, and here's the adjacent. I'm going to use SOHCAHTOA. And we've got information on the opposite and adjacent. Opposite and adjacent. I've got two ticks on the tan. So I'm going to do tan x is equal to opposite over adjacent. My angle, I'm going to substitute in, angle 32 degrees. Opposite is h. Adjacent is 250. Fraction is divided by 250, so multiply by 250 on both sides. That will cancel the 250s out. So I've got 250 multiplied by the tan of 32 degrees is equal to h. And if I go ahead and do 250 multiplied by the tan of 32, then I get 156.21, 156.21, and so on. So what is that? What will I round it to? I could do it to one decimal place, or I could just do it to the nearest unit, to 3 significant figures. The 2 tells me to round down to 156 meters to 3 significant figures, 3 digits. So it tells me calculate the height of the building. I've used h for my benefit, so we need to finish with some words. The height of the building or the town hall is 156 meters. Okay. Example 2. At a horizontal distance of 1.4 kilometers from the runway, a pilot measures the angle of depression as 16 degrees. Calculate the altitude of the plane to the nearest meter. Okay, so we've got the angle of depression. Do you see it? So we're going to be going down from the horizontal. We've got altitude, which just means the height of the plane. Of course, height. I'll write that in. To the nearest meter. Okay, so that's kind of hard. It's like, can you visualize it? Well, let's draw some pictures. Okay, let's draw. Here's the ground. There is a runway, and we've got a plane, right? So let's draw it in. There we go. There's my plane. At a horizontal distance of 14 kilometers away from the runway. So we're going to assume the runway starts, say here. Okay, and horizontal means straight along. Now, what we're imagining is if the pilot's here in the front, then his eyesight is going to be kind of like there. He's looking along to the runway. Okay, he'll be looking down, saying, "Yep." Okay, but at the moment we're interested in the horizontal distance, and that is what's that? 1.4 kilometers, say 1400 meters. Okay, now we're looking for the height. Now that's easy because the height is just straight up and down, right? So from that point where the pilot is, we can draw a line down and say that height is, what's that? Oh, we don't know. Actually, that's what we're trying to work out. So do you notice that this a horizontal distance of 1400 meters, the angle of depression is 16 degrees. In other words, what he's doing is he's looking now at the runway and saying, there's the runway down there, okay? And from his horizontal distance, from that horizontal eye, the angle of depression is down here. That's 16 degrees. Now the good thing is that horizontal distance of 1400 is along the sky there, but you notice it's also going to be this distance here. So we can write that in there, and here we're building up our right angle triangle. We've got a right angle, we're assuming the height is straight up and down. So the only problem is we don't have any angles inside the triangle. We've got the 16 degrees out there. You get two options and both of them are equally correct. One is to say that from the horizontal line of sight to the altitude is also 90 degrees, which means that 16 and something makes 90. 16 and 74 makes 90 degrees. So that would be fine to work out 74. The other thing is, remember I said earlier on that when you're dealing with angles of depression, we often have parallel lines. And the Z-shape angle, you get an equal angle. So that's 16 degrees, 16, 16. Now with trigonometry, it doesn't matter which angle you use. You'll use a different kind of ratio or different fraction, and it'll give you the same answer. So whichever of the two angles that work for you, then that's fine. I'm going to take this away, and I'm going to go with the Z-shape angle. Okay? Just because I don't have to work in now. It's 16 degrees down here. Okay, so now that I've got my right angled triangle, I know what I'm trying to work out. I can just go ahead and do all the bits. Okay, hypotenuse, opposite, adjacent, SOHCAHTOA, and what have we got? I've got opposite and adjacent. Okay, so a lot of the time we're using tan. That doesn't mean it's always the case. It just happens these examples here are tan x equals opposite over adjacent. Substitute in tan of 16 degrees is equal to h over 1400. See, it said to the nearest meter, so I've just changed it to meters so that I'll just round it to the nearest whole number then. So multiplying both sides by the number on the bottom of the fraction. So we've got 1400, oops, I haven't changed my colour, 1400 times the tan of 16 equals h. Take a calculator, 1400 multiplied by the tan of 16 degrees, and we get 401.44401.44 meters. Okay, it says to the nearest meter, right? So I can round that as being 401 meters. So what does the question say? Calculate the altitude of the plane. So let's answer it. The altitude of the plane is 401 meters. Okay, so again, we have to draw the diagram. We're using the idea of angles of elevation, angles of depression. I hope that's been useful, and you can go and practice some questions involving these phrases.